Hi guys, this is O-Level Chemistry, paper 12, June 2018, question 31. The diagram shows a cell that can be used to extract a metal from its oxide. Molten aluminum oxide, copper 2 oxide, lead 2 oxide, and magnesium oxide are each electrolyzed in separate cells. Each cell receives the same number of electrons. Which statement is correct? All the metals can also be extracted from their oxides using coke. No, only metals that are less reactive than iron can. So out of these, we can have copper and lead being able to be extracted by reacting their oxides with coke, not aluminum and magnesium. Next, the anode and cathode should be made of metal being extracted. No, they should be made of inert electrodes. The common choice of electrodes are carbon brushes. The pure metal is always produced at the cathode. Yes, that is the liquid found at the bottom of this setup. And the same mass of each metal is formed. No, it depends on its AR and also depends on how many electrons are required to reduce the metal ions. So the correct option for this question is option C. Question 32. Iron is obtained in the blast furnace from the ore hematite. Which process takes place in the blast furnace? Calcium carbonate is used to remove acidic impurities. Yes, calcium carbonate reacts with the acidic impurity SiO2 and converts it into CaSiO3, and carbon dioxide gas is liberated in the process. Next, coke is reduced to carbon dioxide. No, coke is oxidized to carbon dioxide because coke is carbon. Hematite is oxidized by carbon monoxide. No, hematite is reduced by carbon monoxide. We have hematite Fe2O3. We have it reacting with 3 moles of carbon monoxide. We have the production of metal iron by reduction and the oxidation of carbon monoxide into carbon dioxide. And the last one, hematite undergoes thermal decomposition. No, hematite undergoes reduction. Therefore, option A is the correct option for this question. Question 33. Aircraft manufacture requires a metal that has a relatively low density, of course, because the airplane has to fly, and is resistant to corrosion. Yes, because we have atmospheric water vapor all around and it must not corrode. So both statements being correct or both conditions being correct, we have A as the correct option for this question, because the question has asked us which of these conditions does aluminum satisfy, and aluminum satisfies both of these conditions. Question 34. Which pair of gases are both non-acidic? Okay, ammonia is basic and methane is neutral, so they are both non-acidic. Carbon dioxide is acidic, ammonia is basic. Methane is neutral and nitrogen dioxide is acidic. Nitrogen dioxide is acidic, carbon dioxide is also acidic. This makes option A the correct option for this question. Question 35. Seawater is desalinated to make it drinkable. What is the main substance removed by desalination? Detergent? No. Fertilizer? No. Sewage? No. Sodium chloride, which is the salt present in seawater? Yes. Desalination means removal of salt. So the salt present in seawater is sodium chloride, making option D the correct option for this question. Question 36. Which diagram shows a branch chain isomer of butane? Butane is C4H10. So in A, we have got 1, 2, 3 carbon atoms in the straight parent chain, which is propane, and we have got a CH3 group attached to the second carbon atom as a side group. So this compound is 2-methyl propane, and it has got a molecular formula of C4H10, making it a isomer of butane. B is butane itself, because when we look at the structure closely, we have 1, 2, 3, and 4 carbon atoms in a straight chain. The same thing happens in C. 1, 2, 3, 4. 4 carbon atoms in a straight chain, making it butane. And the same thing happens in D. 1, 2, 3, 4. We have 4 carbon atoms in a straight chain. So options B, C, and D are all butane. A is the only one in which we have a CH3 group substituted onto a carbon atom, making it an isomer of butane, which is 2-methylpropane. Therefore, option A is the correct option for this question. Question 37. A straight chain alkene C4H8 undergoes an addition reaction with bromine. What is the possible structure of the product? So we have got a straight chain alkene, that is C double bond C, single bond C, single bond C is one of the options, and the other option would be C, single bond C, double bond C, and single bond C. So we would have but1-ene and but2-ene as the possible alkene. So if bromine is to be added onto the double bonded carbon atom, so it would either be added on the first and the second carbon atom when the double bond breaks, or it would be added onto the second or the third carbon atoms when the double bond breaks. In effect, two bromine atoms would be present on two adjacent carbon atoms. So now let's look at the options we have. In the first one, we have got CH3, CHBr, then we have CH2, then CH2Br. We have a CH2 in between two carbon atoms on which the bromine atom is present, making this structure incorrect. Next, we have got CH3, then we have got CHBr, then we have got CHBr, and then CH3. This is similar to this structure. So making B correct. C, we have got CH2Br, then we have got CH2, then again CH2, and then CH2Br. We have got two carbon atoms in between the two carbon atoms with bromine on them. This structure is incorrect. And the last one, we've got CH3, CH2, CH2, CH2Br. We only have one Br. We are supposed to have two Br in the structure. Therefore, this is also incorrect, making option B the correct option for this question. Question 38. The diagram shows the structure of oxalic acid. Which alcohol is oxidized to form oxalic acid? So, we have got two carbon atoms, both being part of the COOH group. So, the alcohol that would be oxidized to form this dicarboxylic acid would be a diol. A diol means two carbon atoms with the OH group present on them. So, if two carbon atoms have two OH on them, the rest of the atoms attached to the carbon atoms would be hydrogen. Thus, we would have a molecule of ethanol with two OH groups on it. So, in option A, we only have one OH group. A becomes incorrect. In option B also, we have one OH group, making it incorrect, and also it has three carbon atoms. So, there are two reasons for option B to be incorrect. Option C has two carbon atoms, each having an OH attached to it, which is similar to the structure that we made, making option C correct. And option D has two OH groups present, but with two carbon atoms in between the carbon atoms with the OH group on it, making option D incorrect. Therefore, C is the correct option for this question. Question 39. Some properties of compound G are listed. It reacts with potassium carbonate to produce carbon dioxide. If it is reacting with a carbonate to produce CO2 gas, it is acidic in nature. Next, it reacts with ethanol to produce a sweet smelling liquid. It is a carboxylic acid. And next, it reacts with sodium hydroxide to produce a salt. This is what both acids and carboxylic acids do. So basically, this is a carboxylic acid because it produces an ester. Okay. What is possible identity of J? So we've got options of ethanoic acid, which is a carboxylic acid, ethanol, which is an alcohol, ethyl ethanoate, which is an ester, and ethyl methanoate, which is also an ester, making option A the correct option for this question. Question 40. The diagram shows the formula of nylon. From which compounds could nylon be made? So basically, we are supposed to identify the monomers of nylon. So let's do that. If we start from here, we have got the first amide bond here. So this is the first monomer. And then we start from here, where we ended the first monomer. And we end here at the next amide bond, getting the second monomer. So the second monomer has CH2 repeated 6 times between two NH2 groups. And for the first monomer, we have got CH2 repeating 4 times between two COOH groups. So now identifying the monomers from the list. In A, we've got CH2 6 times with the COOH groups, making it incorrect. B, we have got COOH on both ends of CH4, making this correct. Now moving on to the second monomer, we have got CH2 4 times. We needed 6 times, so this is incorrect. In option C, we've got 4 CH2 groups between two COOH groups, making it correct. And we've got 6 CH2 groups between two NH2 groups, making it correct. In the last one, we've got 6 CH2 groups between two COOH groups, making it incorrect. So the option with both the correct monomers for nylon is option C.